to Valley Mobile Automotive. In this episode, we'll be talking about spark plugs. Each of these spark plugs claim to be made for a 2008 Chevy Cobalt, but are they created equal? Now the OE, or original equipment manufacturer plug for this vehicle is the AC Delco. It's the AC Delco Iridium plug. But other manufacturers, like Autolite, make a couple. This is Iridium from Autolite, but Autolite also says that a platinum will work, and you can buy this for the Chevy Cobalt. Now, as we compare these spark plugs, there's a few things that we want to look at. These are resistor spark plugs. That is this right here that goes onto the coil, either goes here or the spark plug wire goes on here. For a Chevy Cobalt, it's a coil. And this electrode, see if I can show you that electrode right there by the ceramic, they're not one piece. So in between or inside this spark plug, there's a gap with some carbon or graphite in between that creates a resistance. That resistance inside is built there by design, usually a few thousand ohms, depending on manufacturer. Well, that resistance designed into the plug is to reduce what's called RFI, radio frequency interference. And that radio frequency interference can interrupt electronics. And as we know, modern cars have a lot of electronics. So having a built-in RFI reducer or dampener that can help our electronics or surrounding electronics. So a few things we're going to look at when comparing this factory plug to the rest of the plugs. First, it's going to be that resistance between this tip here and our center electrode here. So that's important. What's that resistance? We'll go factory resistance to the aftermarket resistances and have a comparison. But then also that ceramic inside, that's also super important because it does two things. It's electrical insulation. In other words, it prevents that spark from jumping out the side and going from that center electrode to the side of the plug. So electrical insulation, but it's also thermal insulation. So how thick that ceramic is will determine how much heat that plug can hold in between firing cycles. As the voltage jumps from that center electrode to the grounding strap, creates a lot of heat. And also the combustion event creates a lot of heat. Well, this ceramic acts as a thermal insulation, kind of like a thermos keeps your coffee warm. Well, the thicker that thermos is, the better it is at keeping that coffee nice and hot. Well, the thicker this ceramic is, the more heat is retained in between fire cycles, creating a hotter plug. Maybe you've heard that term, a hotter plug or a colder plug. Well, that's what they're talking about, that thermal insulation. So we'll compare that as well. Well, let's get to it. Hopefully you can see that well enough. I have my meter set on ohms. I'll have one of my leads on the tip here, and then the other will be on the center electrode. Now this is factory. So 6.68 K or 6,680 ohms. So keep that in mind, 6,680 ohms for the factory. Next up, we'll go Autolite. This is the Iridium. Autolite also makes the platinum for it. Do the same thing. 7.21 K, so a little more. Next, we'll do Champion. A lot less, 4.89. NGK, another popular brand. And again, lower, 5.37 or 5,370 ohms. Take a look at the Bosch. Closer, a lot closer. 6.76. And then I think that's it. Oh, we got one more, the Platinum. So the OE recommends Iridium. This is a Platinum. This is the least out of all of them. 3.54 or 3,543 ohms. So we saw a wide range of ohmage. Why is that important? The whole idea of a spark plug is to jump electricity from this center electrode to this grounding strap. And that creates a superheated area, causing the fuel to ignite. If there's too many ohms, that electricity can't jump the gap. Your ignition coil may not be strong enough to produce enough voltage to jump that gap. And we're talking thousands of volts, 15, 20, 25 plus thousand volts for those electrons to jump this center electrode to this grounding strap. The more resistance you have, the more voltage is required. Too much resistance, your ignition coil can't produce it. Well, what about the opposite? What effect can having too little ohms have on performance? Well, let's talk about Ohm's law for a moment. If our voltage is a constant produced by our ignition coil, 20,000 plus volts ignition coil, that's a constant, but we reduce our ohms or reduce our resistance, we are increasing our amps or increasing our current. So an increase in resistance decreases current, decrease in resistance increases current. So what can this increase in amperage or current have? What effect can this have on the plug? Well, with more current comes more heat. So more heat is generated as this spark jumps the gap. So that causes at least two different things. One, that heat can have a stress on our porcelain or our ceramic insulation. Too much heat causes a lot of stress that can crack or start to chip or break away at our porcelain. So a more robust, thicker porcelain will be needed, which increases the temperature of the plug, creating a hotter plug. Second, all that amperage or current, that increase will have an effect on the surface of our center electrode and the surface of our grounding strap, causing faster or increased wear of those two surfaces. So your maintenance interval has been shortened. A lot of manufacturers nowadays recommend iridium plugs to be changed every 100,000 miles. That's a lot of miles. That can be, 8 years, 10 years, even more for some vehicles, depending on how much they're driven. So it's possible that the aftermarket plug could have a reduction in service life because of an increase in amperage or an increase in current flow through the plug. So that's a possible side effect and something that you may not notice right away. But over time, it'll exhibit itself as a worn out plug, even though you maybe haven't reached the full 100,000 mile mark. So now let's talk about the insulation. This ceramic insulation, let me focus it. Again, it serves two things, electrical insulation and a thermal insulation. What we're interested in is the thermal part of this insulation. This is the AC Delco, and we'll compare it with the Bosch right here. Now the Bosch had a very similar ohm reading, but maybe you can see the insulation difference. This meat here versus that meat there. This has more insulation than the factory plug. So this plug, the Bosch, is a hotter plug. It won't cool off as much in between firing cycles as the OE will. This is Champion. So you can see same thing. It's a thicker insulation. Let me turn this plug around. So thicker insulation, a hotter plug. Autolite. That's very similar. More similar. I'll set that aside. NGK. Still fatter. This is the other Autolite. I believe this one is the platinum, and then this one is the iridium. So similar. The Autolite looks like it's the closest out of all of them. Well, as we saw, most of the aftermarket spark plugs had more porcelain insulation than the factory plug. Well, why is that important? If your spark plug burns too hot or it holds too much heat in between firing cycles, you can get what's called glaze on the plug. That is, the fuel will start to crystallize or caramelize on the plug, and you could actually foul a plug because it's too hot. So you need a cooler plug. The OE plug's insulation was the least, therefore this is a cooler plug, less susceptible to glazing. So even though all of these plugs can be used for a 2008 Chevy Cobalt, all of the aftermarket plugs fall short of the original equipment, AC Delco. And this doesn't mean that AC Delco is the bee's knees in spark plug manufacturing. It just means that they have specifically designed this plug to perform a specific way in a particular application, that is the 2008 Chevy Cobalt. Well, for a little bit of fun, let's cut this AC Delco plug down the middle. We'll cut one of these other aftermarket plugs down the middle and just get a good comparison of what they look like inside. What does the guts look like? So it took a couple tries, but I finally got a good one. Get it in the camera. So this conductive material runs down through the ceramic here and then out to right here. And then you can see a change in color, change in material. This is the resistive material that creates our ohms in our resistive plug. That's an RFI suppressor material, usually carbon, graphite. Then we pick up again right here with another conductive material that comes down to our iridium tip. So that's the inside of a plug. All of them will be very similar. This one didn't turn out very well. Not even sure if you could see it, but right here is the bottom conductive material that comes down to the tip. And then this right here is all our resistive material, and then back into our conductive material. So that amount of resistive material determines its ohms. And if you do them side by side, it's hard to see in the camera that this factory plug resistance and the amount of material in here versus this aftermarket plug and the amount of material in here are different. And you can see that once you pull them apart. So that is the inside of a spark plug. Pretty cool. So in conclusion, the best plug for your vehicle is the one that came with the vehicle off the showroom floor, the original equipment. For many Asian vehicles, Honda, Toyota, Nissan, they'll use NGK. Domestic vehicles, Chevy will use AC Delco, Ford will use Motorcraft, Dodge sometimes will use an NGK, a lot of times will use a Champion plug. But to be sure, always check with your local parts store and ask for the original equipment plug for your vehicle, and you'll never go wrong. All right, thanks for watching. Like, subscribe. See you on the next one.